Alright, so here we have some VSEPR practice problems. So the first one is H2O. So in order to find out the VSEPR configuration for H2O or water, we need to draw the Lewis dot diagram for the atom, and we need to take into account that hydrogen needs one bond to fill up its outer shell, and oxygen needs two bonds for that to happen. So if we do it like this, then we find out if we do our Lewis dot diagram like this, we can see how each hydrogen has its one bond, and the oxygen has two bonds plus four valence electrons. So when we count that up, we see that oxygen has one, two, three, four, five, six, and seven, eight valence electrons, two from each bond, because it's sharing one with hydrogen, whereas hydrogen has two of them that it gets from its bond with oxygen. So because H2O has four things surrounding the central atom, that is a general shape for a tetrahedral configuration. We see that our central atom is oxygen. It's surrounded by two hydrogen atoms as well as two pairs of electrons. Because two of those things are electron pairs, the true shape is a tetrahedral bend shape, which looks like this, and each atom is angled about 104.5 degrees away from each other. Next, we go to NH3. So if we draw the Lewis dot diagram, we see that nitrogen needs three bonds and hydrogen needs one bond. And in this dot diagram over here, we see that nitrogen has two electrons from each bond that it has with hydrogen. So we get six electrons plus its pair of electrons on top, which makes it a perfect 8. And hydrogen fills up its shells with the two electrons, one that it has and one that it shares with nitrogen. So because this also has four things surrounding the central atom, which is nitrogen, and this is also the shape for a tetrahedral configuration. However, this time we have three atoms surrounding nitrogen and only one electron pair. So the true shape is a trigonal pyramid shape, and its electron angle is about 107 degrees. Next we have CH4, and we've got to keep in mind that carbon needs four bonds and hydrogen needs one bond. So carbon is going to be our central atom in this, and it's going to get two bonds. It's going to get one valence electron from each hydrogen that it bonds with, and it has four of them on its own. So each of those bonds carries one pair of electrons. So 2 times 4 is 8. So carbon is filled up, and each hydrogen only needs two to get filled up to noble gas status, and we see that it has two in each bond that it shares with carbon as well. Now CH4 has four things surrounding the central atom carbon, but this time we have zero electron pairs and four atoms surrounding carbon. So this is your basic tetrahedral shape, and the angle is about 109.5 degrees. Alright, that's it.